Hello everyone, welcome to our second webinar, which is called Get Ready for the Regional, How Do I Win? I would like to make you aware that this webinar is being recorded. There will be a Q&A session at the end of the presentation, and if you have a question, please could you put it in the Q&A box or the chat. I will also open all microphones, so if you would like to speak and ask a question, there will be an opportunity. For your information, we have an FAQ page on our website, and you can also email us a question at designchallenge@imeche.org. I'll be handing over shortly to our IMechE Design Challenge Chairman, Davide Migliorini, who will talk about the importance of deadlines and will give you some areas where you can make quick wins. After which, we welcome Matt Lister, our head judge, who will give you some more detail on regulations and scoring criteria. And we shall finish with the Q&A session. And now, over to you, Davide.
Good afternoon, and thank you, everybody. It's a pleasure to be here. Right. The title of the webinar is you now won your internal selection at your university. Now, what's next? Is getting ready for the national final, for the regional final. Apologies, that will be the first step. So the regional final will be the first moment where teams of different universities with different course structure will come together, and it will be a great point of learning for all the students. So we encourage everybody to be there and have joy and have fun during the day. Of course, this is a competition, and we know that all the students are incredibly happy and competitive. So the question number one is that how to win, how I will get scored. The scoring is detailed at the top level in the general specification in section 1.5. This section will list the different elements of the different competition, how then the score will be compounded to get the final and overall winner. Some important bit that Alice just mentioned is getting ready for the regulations, for the registration. How should I register? So the IMechE has a contact page for the registrations. Just be mindful to be on time with your registration and further on with the deadlines for all the other submissions. Next, please. So the regulations are split in two different documents. One is generic that talks about overall what is the purpose, the scoring, the different sections, the different elements of the competition, and one is bespoke to the project. As you know, the design challenge run on a number of projects that are alternated, and right this year we launched an internal and external challenge competition to suggest new devices. The overall set of rules for this year is about 58 pages that span through all the technical aspects. The IMechE and the Design Challenge Committee believe that this is a palatable and digestible number of pages, so nobody should be worried or afraid of reading through the pages. We encourage all the students to read all of the pages in case some courses and some lectures focus only on some sections, and not to miss all the other bits. The reason is that in the regional finals and then in the national finals, the overall evaluation of the project will be a comprehensive aspect of everything else. Something very important and very key, safety by design and during the execution of the prototype is taken very seriously. Please ensure that you read the guideline, and any time that you have a concern or some level of confusion or clarification needed about safety, please don't hesitate to get in touch with the Design Challenge steering committee members. The student should okay, so one of the elements of the competition is talking about the presentation. The competition has, whenever there is a physical device, so for the foundation and advanced course, this is not present into the concept class. The main part, so the main score is based on the physical prototype. That takes about 60% of the final scoring. However, to get a valid score and be accounted for winning everything, all the bits of the competition need to be completed to a successful outcome. This includes creating a presentation. Now, creating a presentation is important because it is a moment of technical communication to a potential non-technical audience. So there are a number of things that that students will face. Is first, trying to explain their work in a way where everybody could understand it. At the same time, try to include with the right level of detail all the elements of the competition. All these activities require a level of testing, a level of training, and by providing a video filmed presentation that fits within a specific timing, that will give it to the student the opportunity to practice and become better at presentation. Unfortunately, there is no magic recipe for a good presentation. By doing practice, by getting ready, by finishing and honing and polishing, you will get better every time. One of the suggestions is what we call the grandmother test. So pick up any of your friends or your neighbor that hopefully don't know what you're doing, and better if they don't understand what you're doing. Run them through the 5 minutes of the presentation. If they get the message, if at the end they are capable of summarizing and say, oh, you did this job and this thing need to do A, B, and C, then you achieved your goal. It means that you have been able to communicate clearly to a broad audience the technical detail of your project. This skill will be heavily valued in the future. When you run for a business or you try to catch a business, presenting your project is equally as important as the project itself. A bad presentation will not engage a potential customer, and they may be not willing to invest in your idea. So although this design challenge is about building and running with a device, showing that you did all your best to achieve that point is very important. Next, please. Most of the students ask us this question about do I need to plan a lot, or do I need to just jump in, make it happen and see what happens? A bit of both, a balance is required, and that is mastering how much planning and how much not planning is a very fine art that only with experience will be achieved. One of the suggestions is that okay with planning, but try not to overkill your schedule with a lot of time management, a lot of detailed steps, a lot of project management. Ultimately, a project manager that will be allocated, that you may allocate to this job, will not use or should not use a lot of time. The student that is performing the function of the project manager should have enough time to perform as well other tasks. In your planning, try to plan for the success. Don't put in steps about failing. When failure will arise, try to manage the failure, try to manage the contingencies. Now, something somehow wise, it's set aside at least a portion, let's say up to the 20% of your timing in contingencies. Those contingencies could be physical failure of the prototype, delays because the purchase order didn't get approved on time, so you don't get the parts to run your component, some failure on your IT equipment that you may use to present the poster or the presentation, or a physical delay in your design. So at the same time, try not to be too much focused on failing, because the purpose is being focused on winning. Next, please. There is no magic recipe again for a project time split. We have tried here to set up for you a beginning, a baseline on how much time you could spend in your time budget allocation. The time that every student or every team has differs depending if the job is done as a part of the curricular activity or if instead is done as extracurricular activities. We know that all the projects tend to overrun in time, but at the same time, we try to encourage you to use efficiently the time that is available for this activity through your university. This split is a a sensible approach to focus on the physical part when it's right time to do it. So you may see that there is a big portion, so about 40%, which is from the physical build to the testing development and the last wrapping up, final fixing on the device or onto the presentation and all the other bit. However, the more accurate is your initial part of the phase where you analyze all your ideas, you then narrow down to only one, and then you get to align your design, your BOM, and your CAD and preliminary calculator of your performance. The smoother will be the landing into build and testing your device. Next, please. So the deadlines are very important, and one of the introduction from this year is that if for any reason submission would be done late, there will be a penalty. One of the reasons is that we consider student that work on time as the student that has put all the effort to be on the required point for the submission, and we could consider people that have done a late submission to have taken a not necessarily fair advantage over teams that have submitted ahead of the timeline. So please check the documentation, create your own calendar, and stick to the deadline for submission. Whenever you submit something which is not complete, as per the regulation, you may not be entitled to the full and final evaluation for the winner. What it means for the regional is that although you may have a perfect device, but you didn't submit, for example, a poster or all the other stuff, you may not be able to be selected to go to the national finals. So ensuring that you submit on time all the elements of the competition is quite key. If you look into the regulation, there are a number of bits and things that will get you to achieve some easy wins. Easy wins mean, for example, you get scored for the poster about the orientation of the PDF, the correct size, the correct format, as I already mentioned, the PDF, a clear logo for the university, clear set for the students, and the picture of the device. All of these are something which are incredibly easy to be achieved and will give you a solid punctuation. If other elements that are incredibly important to present a project are not that clear, at least you are creating a baseline that may take you only half an hour for your document, and you will get a PDF ready in any second for the submission. Same, for example, for the CAD. The CAD submission is required to be in a dot step format of the full assembly. So at any point where you're ready, try to save your CAD file as a dot step and then reopen it from a different laptop to check that your assembly is complete and correct. Sometimes by generating the step file, areas will get deleted or components will get out of space. The design evaluation is done on the CAD that you submitted. Similar story with the BOM. So if there is a misalignment between the BOM that you submitted and the BOM that you present, that will be considered. Next, please. So for the foundation and advanced categories, there is the element of the physical build. We often get a number of questions for a number of different approaches. Where should I start to build? How should I start to build? What is the right element for building? Again, it really depends and vary on the purpose of your activity at university, and the IMechE Design Challenge Steering Committee is not meant to replace any element of your university. There are here a number of suggestions. This challenge is named Design Challenge, so the purpose would be to do a design of a component and then build to check that your design conditions were met. The recommendation for building would be clearly to test if slightly different solutions could give a different outcome. For example, you may not be able to calculate a different coefficient of friction for two wheels of the same size. don't invest time in trying to find a formula for it. Just build 2 different wheels in 2 different materials and get them to test. Or there could be an area of your structure where it will take too long to calculate what are the loads, and as such, how thick or which material you should use. Focus the build phases on debugging high-risk areas, and focus the build phases on testing small solutions where you're uncertain on, and you don't really have time to invest into the virtual analysis or the engineering calculation on this. Sometimes people tend to start with a sketch of an idea and just jump into making it without putting too much planning into it. Things that could happen in these cases, given that all the devices have a level of electrical connections, people may forget that there is a battery, there is a switch, there is a cable that should be housed somewhere, or that we need a lot of fixings. That may become evident when you do a fly-through from the CAD into the BOM and then to the physical prototypes. When you don't really invest a lot of time in creating your accurate CAD model, you miss parts that may then contribute to be close to the bottom of the BOM allowance, or even be beyond the bottom the BOM allowance, and as such get a penalty. So our recommendation is always to, within time and within sense, be accurate on your CAD modeling, and then build and test, focusing on the little solution that may have required too much time to be scoped out on the virtual screen. At this point, you may have left some little bit of budget or some little bit of time, or maybe both. So if you made your device, which is working, is doing the job, is performing, if you have any spare time, that is the moment where you could step in and try to do some improvement. Always be mindful that the physical model, the CAD model submitted, the poster, and the virtual presentation, so the filming of the presentation, should all be aligned. So any time that later in the program you put in place some improvements, all of these should be retrospectively reintroducing all the elements that you are going to submit. Next, please. Now, thank you very much for your time. And at any point, please feel free to ask us any question. We'll then hand over to Captain Matt Lister, which is the new Design Challenge head judge.
Afternoon all, and thanks for the introduction, Davide. So my name's Matt Lister. I'm Royal Naval Officer. I run engineering within the nuclear propulsion team down here at MOD Abbey Wood. My main role is safety engineering and management of safe engineering within design of nuclear reactors and management of reactors through life. As Davide said, it's my first year as head judge, so please be gentle with the questions. But I thought useful just to talk you through a couple of my thoughts as regards the sort of rules and the scoring. So next slide, please. Yeah, I think worth bearing in mind that engineering rules are quite important. I've shown you some examples there of engineering disasters and safety issues and problems, most of which have at their heart a failure to adhere to rules, or a failure to adhere to kind of regulations in engineering design. If you can recognize any of those pictures, feel free to shove it in the chat section of the MS Teams. They're important for safety, and they are, and that's the genesis of most kind of regulation, if you like, that engineers have to deal with in design. So management of risk to life, management of protection of the environment, that all comes into what is the basis of regulation. But you'll also, in addition to that, you'll have requirements that are set out by your customer. So your customer will tell you what their specific rules and regulations are. And that will govern what you're doing. There will also be some rules and constraints that you set on yourself as designers, because you need to, for example, impose a financial constraint, because if you don't, you won't be able to turn an affordability position on a product that you're designing. So it's normal for engineers to deal with lots of rules and regulations, and that's why we try to reflect that in the Engineering Design Challenge. The other main reason that we impose rules and restrictions on what you're doing is we need a fair playing field. we need to introduce some constraint to your design efforts so that all of the teams have a fair and kind of balanced playing field to play on. So that's kind of the main reason why we insist on the rules and the regs. Next slide. Everything you need to know about the rules and regs is in the general specification. I would encourage you to read that. It has a breakdown of what the specific rules are against each of the main kind of areas of the design challenge. And if you need those, they're in section 6, 8, 10, 12 and 14. That document is available on Google. You don't need a special permission to go and look at it, so anybody can get in there. The rules are kind of broken down into 4 key areas. There are specification rules against your overall design. So that's volume, the types of materials you can use, what we're looking for in a 3D model. There are operating rules, which talk about the autonomy of your vehicle, the way that you can control it, how you recharge it. We've then got administrative rules, so risk assessments, the BOM, audits, poster size, branding, and then we've also got some OSHI rules as well. So that talks about fittings, fixtures, PPE requirements for you and your design team to adhere to. Next slide. Yep, I said that the rules are all about level playing field. Some of the rules are also for your safety, so please do adhere to them carefully. You know, you're not at massive risk with this design challenge. It's at fairly low level in terms of the hazards that you're being exposed to, but we maintain that through adherence to rules, and this one's a good example. So please don't use any explosives or combustible fluids in your design. Hilarious as that would be for us to judge. Okay, next slide. Yeah, so in a similar vein to what I'd said about rules, the scoring criteria is all within that general specification, and the sections are up there for it. It breaks down to the scoring allocations that you can see there on the slide. So design, poster, presentation, the peer reviews, that's for regional only, the design excellence bit, that's for the national event, and the challenge itself. You can see that the challenge is the kind of dominant component of the overall scoring, so it's you know, important, but you cannot submit a winning design unless you've attacked all elements of the scoring criteria. So you can't sort of dismiss the poster and say you're going to bank all your efforts on challenge itself. We need a submission for each of those elements, and you need a score against each of those elements. The others are important, and you know, it will add up and give you an overall score. And you know, I would say to you, if you're looking to win, or if you want to do particularly well in this event, you're going to need to target good scores across the across all of the scoring criteria. So please treat them equally in terms of how you target those. There's lots of detail in the general specification that can help you understand. And just like, you know, in the real world, when you do engineering challenges, if you can understand what your customer values, then that's going to give you a massive leg up, particularly where you're targeting competitive design challenges. And those do happen. So, yep, please have a read through that. And if you did have any questions today, we're very happy to take those. I think next slides. Yep, that's it from me. Up on the slide at the minute, you can see all of the members of the steering committee. You know, we're all available either on the day in the sessions or in any of these webinars to take your questions or to talk you through any of the queries or issues you might have in relation to any aspect of the design challenge. So please do feel free to reach out. I think I'm going to pass back to Alice now, because we're over to Q&A.
Thank you, Matt. That was excellent. Great, really informative, and loved your images as well. I think we do have some questions in the Q&A and in the chat. No, in the Q&A box.
Yes, just for the benefit of everybody, there were 2 very interesting questions raised in the Q&A. For university of students that were used to compete in the previous year, we were requiring to show evidence of the invoice and or evidence of the purchase of some activities. That was creating a lot of unnecessary time consumption of some students, because most of the university may buy materials as a bulk. So extract those invoices from the university system was deemed to be too time consuming. At the same time, materials that sometimes are gifted by third parties that support universities sometimes happen. Now, there is a change in the approach to the BOM calculation. For this year, to help, if possible, finding potential better sources or better costing for material, we allow all the students to find a reliable source for the material they are using that may or may not be where they bought the material, and they show us a costing. Try please not to abuse on this stuff. So if everything comes from Alibaba, including the plywood, we know that the plywood has been provided by a UK source to a university or a lab. So try to be sensible about something. Sometimes Far East suppliers are great for batteries, for motors, for gearboxes, and is pretty much the only source where you can get those from. Most of the consumable material are available through a lot of cheap merchants here in UK or broader in Europe. So just go online, find a reliable source for the material you're buying, and use that as a baseline cost. Another very interesting question was about the risk assessment. We leave the risk assessment to the universities or the colleges there. For us, it's important that in the event of the final and eventually the regional, and that it needed as well the national one, a risk assessment that cover what is the physical interaction on the day is there. So please ensure that every aspect of your operation have been evaluated by a representative of the institution you belong to, and is available, is signed, and you're all happy with the level of risk analyzed and what is covered there.
Yeah, I might add just a couple of thoughts there. So as far as the BOM goes, I think in answer to Matt White's question, there's no such thing as free components. Usually when engineering component companies talk about free componentry, there's usually some sort of tax avoidance at play there. So you need to put down a value, even if it's not a cost that you've had to make as part of the university, because it's materials that you had readily accessible to you and you didn't have to purchase direct. So to Davide's point, make sure that you can put down a value. Matt's also asked a quite an interesting question about risk assessment. The risk assessment that's required is for the competition phase. So it's the specific activity associated with the competition. However, when you're doing manufacturing activities in your university will have risk assessments for its workshop and for those activities, which you will clearly need to adhere to. So although we're not telling you we need a risk assessment for what you do in the manufacturing and the build phases, you should be cognizant at all times that your institution will have safety processes in place and risk assessments in place, and you need to adhere to those when you're doing your build.
Very good integration to what I said, to cover and hope to expand a little more on the risk assessment example. Let's say that by design you decide to have a circlip, which is a circular spring that goes into a groove to retain a wheel. Fantastic, that is a great idea. However, please be mindful that by inserting and removing the spring, this could fly off. So in the operation to insert and remove the circlip, you need to have a level of PPE and do it in a certain way. If you instead use a push spring, so something that is called sometimes as well as a star lock or something like that, there will be no use of additional tool that could harm or could potentially risk to fly away and create an hazard. What does it mean? On your build, as Matt was saying, please be mindful on what are the limitation or recommendation within your lab. If removing or interacting with this circlip is required on the day of the competition, and please be mindful that things could go wrong, so you could have a wheel that falls off and you need to replace it or something like that, just ensure that all the necessary PPE and all the necessary risks are evaluated by carrying out such activity in a space where there are other people and possibly outside the lab. So again, be mindful on what you do in your lab. At the same time, be mindful of what you may decide or may have to carry out on the day of the regional or on the national final, and ensure that everything is always done on safe. A personal comment on risk assessment and the safety, where I'm incredibly adamant on. Please protect every electrical installation, every electrical wire, every electrical junction. Even if we are running on a very small battery, exposed conductor could be violated by a short, with a tool, with a spanner, even with a pen if it has a metal body. So please ensure that all the electrical connection, whenever you do them, are suitably protected in any moment of the competition. So no hanging wire, no just exposed solder will be accepted. On the day of the competition, that will be part of the scrutineering. If electrical connections are exposed, the vehicle will be sent back to be fixed and re-scrutineered. If you cannot fix and protect all the parts, you may not be allowed to the competition. So just have safety in mind so that everybody could have fun and have a little bit of learning from this activity.
Thank you, Davide. We do have some more questions further up in the Q&A around the 3D model of the vehicle, pre-scrutineering form, and the video.
Apologies, for some reason I didn't see the other one. So for the 3D model of the vehicle, do you have to model all the components ourselves? Can you use CAM model from the manufacturer? Of course. That is a very, very valid time saving. If you find a reliable source that will provide a 3D model for what you're buying, why not? That is exactly what happens in general industry. So if you buy in general industry a bearing from a reliable supplier, they will provide you a 3D model, and you will use such 3D model straight from them. Then there is another question about pre-scrutiny is informed device signed off by an academic advisor as a PDF. What is this? Any of your institution representatives that will bring you as a team into the regional final should sign off an internal university document to say that they are happy with what vehicle has been produced, the physical part of it, and how safe and how it has been executed and implemented. Clearly, this is not applicable to the concept category because there is no physical vehicle there. We don't want to enforce a standardized template. It's just leaving to every university to analyze the capacity of the vehicle, the risk associated to on running it and putting it in service, and ensure that a third party within your academia or institution is happy that the vehicle is safe. Now, from Calvin again, there is a question. The rules state that the video is a time constrained, is 5 minutes. It is written somewhere else in the rules. I'm really pleased to see that most of you that are interacting today have started to read the regulation. So thank you very much, really appreciate it. So it's a 5-minute maximum. We don't have a direct penalty for people that use more than 5 minutes, but it will become evident into the scoring. So if you see the scoring criteria for the video, part is a clear communication, and for example, as a judging panel that you decided that actually a video which is too long, it is not really a clear communication, it's consuming too much time, and as such, on that particular aspect, you may score lower. Then again, on the presentation, is the video just a recording of the presentation or a slick edited video with a sound track and other stuff? We'll leave this up to you. The video should be the presentation of your project. The clearer is your presentation, the more detailed. So on the job that you did, the easier is to understand for everybody that has not seen your vehicle. So they will approach your vehicle by seeing the video for the first time, the better is your output. Something that may happen is using like a video projector to project a slide and people speaking in the background. Sometimes be mindful on the light reflection on the recording, given that the judging panel will analyze your video. If there is any light reflection on the recording that may blur your presentation, we may not be able to really see and understand the presentation.
I think if it's useful as an add-on to that, there are no rules that specifically prohibit things like you're describing there, you know, soundtracks and, you know, flash video editing. But if you look at the scoring criteria, you'll see that that's not really something that features. So I think it's possible you might be in danger of trying to put efforts in and put extra material into your presentation that, whilst fantastic isn't necessarily going to add to the score. You'd have to make a judgment yourself based on the scoring criteria and the sort of ideas you've got in your head for what you want to present. There's certainly no expectation of that if it's useful just to help clarify. But equally, there is no restriction on it. There's nothing against it in the rules. So it's up to you as a design team how you want to convey your presentation to the best effect.
Thank you. We have got a question about registering, team registration, and is the team leader or student in charge the point of contact, or an academic? And I believe it's the academic is the team lead point of contact. Don't believe we have any more questions in the Q&A. So I can unmute everybody, and if you have a question you would like to ask, please go ahead. That would be fine for you to do that now.
I think there was a question regarding the pre-scrutineering form / device sign-off by an academic advisor as a PDF. What is this? I don't know if that question's been addressed yet.
Yeah, I think Davide answered that question. Davide, did you have anything more to add for that one?
I'm just adding in writing a summary of the question, so that will be created by each individual institution to cover the minimum content required as a sign-off for safety for the device. So it's your institution representative that will send that team, will sign off that team is okay to go somewhere else in a different university, or maybe at the IMechE headquarters, and everything they are doing on the day is safe and is in line with what the university is expecting the student to do.
Mm-hmm. I have a question actually, Davide, if you have any advice for how to handle an unforeseen problem with the device that may arise on the day of the regional final.
This is unfortunately, this happens more often than what you imagine. Now, my suggestion is stay calm and carry on and go to the regional, go to the final. The reason is that you may find out that during your trip in train, or you may find out that during your landing during the presentation, you can access to some glue, some fixings provided by somebody, and you may be able to get your vehicle to attend. Let's say in a unrealistic but possible scenario where 8 teams registered to attend a regional final, but actually 4 of them forfeit. Of these 4 of them forfeit, there is a likelihood that some of the device will get damaged during the competition or will get disqualified. An example of a device that will disqualify, if the device is hitting the barrier, the vertical barrier, and instead of reverting back straight, it will cross on all the other lanes, perturbating the execution of the other, that device will be disqualified. All of a sudden, there are only 3 devices going there. If you manage to fix the device and do an execution, given that the execution is measured on the precision and not on the timing, then you may have a chance to grab some points and potentially even pass the national. So the suggestion is, if something goes wrong, don't panic and don't get depressed, but just get to the regional final. It will be, even if it's just to meet all the other students and see what they've done, you could still access your presentation, your poster, evaluation, the design, and maybe in all this time somebody will get to help you and get the vehicle back up and running. So never surrender if it's possible.
I think it's worth pointing out that 40% of your overall score is separate from the design challenge. So you can already be accumulating a lot of points and a lot of score before you even get to the competition itself. And just because you have a a technical fault or a technical challenge on the day doesn't mean you're going to walk away from the competition event with a 0 score for that element. Even if it's not as high a score as you're hoping, if you combine that with great marks in your kind of poster challenge and the other aspects, then you can still get to a winning score. So as Davide suggests, it's don't give up and surrender because you've had a disappointing technical challenge at short notice on the day. There's still loads of marks you can grab and enough to get to a winning score.
Excellent. Okay, I don't see any more questions. So if anybody has a question that they think of after this webinar, please email us at designchallenge@imeche.org and we will get back to you with your question. So yes, I think this concludes today's webinar. Thank you all for your time. Thank you for joining. This is being recorded, so the recording of this will go on to YouTube, and we can also send around a PDF of the slides. So thank you very much, everybody. Goodbye.
Great. Thanks all. Cheers. Bye.
Bye all.
Bye bye.
Bye.